have those, and it's anywhere that the derivative is 0 or undefined. So then we did one maybe example where we worked out everything and found the maximum or minimum. So I wanted to just practice that a little bit. We're going to have to do our derivative of this. What might be useful before I jumped in with the derivative? Distribute. You want to start there. That way we don't have to do the product rule. So 3/5 times 30 be 18x minus 3/5 x squared. So f prime, derivative of 18x be 18 minus, if you bring down your 2, 6/5 x. Okay, is this ever undefined? No. If you have a fraction, you have to look at what makes the bottom 0. If we have like an absolute value, we have to look at that breaking point because it'll be a z. It'll be undefined there. But for this case, it's just polynomial, so we're good. So if we just set that equal to 0, add over my 6/5, you multiply by the reciprocal. 18 divided by 6 is 3, times 5 is 15. Okay, this is, remember we called it a critical point, or a critical value. So if I ever ask for those, that's anywhere the derivative is 0 or undefined. Now, I want the actual maximum or minimum, so we test the endpoints and this value. If I had gotten a second x value, let's say like -2, would I use it? No, you have to test every x value that falls in this interval. It is possible that you might get some that aren't in the interval, and then we just disregard them. So we need to test 0, 15, and 30. We're plugging these into the original. If I put in a 0, 3/5 times 0 is 0, times anything would be a 0. If I plug in a 15, 3/5 times 15 is 9, times 15, 135, is that right? If I put in a 30, that parenthesis c is 0, so the whole thing is 0. So, my minimum is your lowest y value, which we actually have a tie. So this would be a minimum. Technically, I should say absolute min. If you just said minimum, that's fine too. And this would be our max, just on that particular interval. Any questions on that one? Let's get another. Find a critical number. So this time I didn't even ask for a maximum or minimum. You couldn't give it to me anyway because I didn't give you a specific interval. So the critical numbers are anywhere the derivative is 0 or undefined. So we need our derivative. Keep in mind, this is 3p squared over p squared minus 4. So what do we have to do? Quotient rule. Low d high, derivative at the top would be a 6p, minus high d low, derivative at the bottom would be a 2p, over low squared. Okay, so if we distribute 6p cubed minus 24p minus 6p cubed, okay. critical points have been two places. Where this derivative is 0 and where it is undefined. If I want to figure out what makes it equal 0, you would just multiply off the bottom, divide by -24, and you get p equals 0. How do you figure out where a fraction is undefined? So if you do a square root, add over your 4, square root again, plus and minus, so that's at positive and negative 2. Those are the places where it is undefined. So my critical points are not x, p is my variable. -2, 0, and 2. If I were finding maximum or minimum, I would have to test all of those in addition to the endpoints that I gave you. Any questions there? Would you like for me to do any more of these? I put extras on there if we needed them. Yeah. Number 8. Let's look at that one. An absolute value. Okay. Before we do the derivative, anytime we had absolute values, we rewrote them with their piecewise definition. So let's do that. Our breaking point is going to be what makes the inside 0. So what would make x minus 2 0? 2. So we'll have one case if x is greater than 2, one case if x is less than 2. When x equals 2, what do we know is going to happen? That's going to be the v of the absolute value. So that's a place where the derivative is undefined, right? So I know right now I will have a critical point when x equals 2 because my derivative is going to be undefined there. Alright, if x is bigger than 2, does the absolute value change anything? No, so you could just drop it. And so this would turn into 3 minus x plus 2. So that becomes a 5 minus x. If x is less than 2, the absolute value does the opposite of that. We get 3 plus x minus 2, so we get 1 minus x. Yes, thank you. Alright, so now if we did our derivative, we just do the derivative of each piece. What's the derivative of 5 minus x? -1. What's the derivative of 1 plus x? 1. Okay, now we have to find out anywhere this is 0 or undefined. We already know it's undefined at 2 because that's the v of my absolute value. Derivatives don't exist at sharp corners. Does -1 ever equal 0? Does 1 ever equal 0? So there are no other critical points. So I gave you an interval, 1 to 4, so we have to test 1, 2, and 4. We plug those into the original. So if I put a 1 in the original, I get 3 minus the absolute value of 1, of -1, excuse me, so 3 minus 1 is 2. If I put a 2 in, I get 3 minus 0, which is 3. If I put in a 4, 4 minus 2 is 2, so 3 minus 2 is 1. So what's my minimum? F of 4 equals 1, and my max? F of 2 equals 3. Do you want me to work out any of the others? So yesterday we had book problems. Can we grade those real quick and then we'll work on this last piece?